When calculating wire ampacity, it's essential to consider the temperature limitations of all components in the electrical circuit. The ampacity tables provided by organizations like the National Electrical Code, or NEC, are designed to ensure safe operation by preventing overheating. These tables specify the maximum current a conductor can carry continuously under specific conditions without exceeding its temperature rating. The weakest link principle applies here. This means that the component with the lowest temperature rating dictates the overall ampacity of the circuit. In the situation where you have 90 degrees Celsius rated wire, but the terminals or lugs are only rated for 75 degrees Celsius, you must use the 75 degrees Celsius column in the ampacity tables. This is because the terminals are the limiting factor. They cannot safely handle the amount of current that the 90 degrees Celsius wire is capable of carrying without exceeding their rated temperature. Using the 90 degrees Celsius column in this scenario would lead to an overestimation of the circuit's ampacity. This overestimation creates a dangerous situation. The conductors could be loaded with more current than the terminals are designed to handle. The excessive current flowing through the 75 degrees Celsius rated terminals would cause them to overheat. Overheating can cause a multitude of problems. Firstly, it degrades the insulation of the wires connected to the terminals, potentially leading to short circuits or ground faults. Secondly, it can damage the terminals themselves, causing them to loosen or melt. Thirdly, and most dangerously, it can create a fire hazard. The NEC provides ampacity tables, such as those found in NEC Table 310.15b16, which list the allowable ampacities for various wire sizes and insulation types at different temperature ratings. These tables are based on specific conditions, including the ambient temperature and the number of current-carrying conductors in a raceway or cable. To correctly determine the ampacity of your wire, you would first need to identify the appropriate table based on the wiring method and insulation type. Then, you would find the column that corresponds to the 75 degrees Celsius temperature rating. From that column, you would select the ampacity value that corresponds to the gauge of your wire. It is also important to consider ambient temperature correction factors. The ampacity tables are typically based on an ambient temperature of 30 degrees Celsius, or 86 degrees Fahrenheit. If the ambient temperature is higher, you must apply a correction factor to reduce the allowable ampacity. This is to account for the fact that the wire will already be starting at a high temperature and therefore will be able to carry less current before exceeding its insulation's temperature rating. These correction factors are also provided in the NEC. For example, if the ambient temperature is 46 degrees Celsius, you would need to find the correction factor for a 75 degrees Celsius rated conductor at 46 degrees Celsius and multiply the ampacity from the table by that factor. This will give you the adjusted ampacity for the wire in that environment. Furthermore, conductor dating factors must be considered if there are more than 3 current-carrying conductors in a raceway or cable. When multiple conductors are bundled together, they generate heat that can affect the overall temperature of the conductors. The NEC requires that the ampacity of the conductors be derated to account for this heat buildup. The derating factors are based on the number of current-carrying conductors. For example, if there are 4 to 6 current-carrying conductors, the ampacity must be derated to 80% of its original value. Again, these derating factors are available in the NEC. In summary, to calculate the wire ampacity in your situation, you would follow these steps. Firstly, identify the lowest temperature rating of any component in the circuit, which in this case is the 75 degrees Celsius rating of the terminal. Secondly, select the appropriate ampacity table from the NEC based on the wiring method and insulation type of the wire. Thirdly, find the 75 degrees Celsius column in the table and determine the ampacity value for the wire gauge you are using. Fourthly, determine the ambient temperature and apply any necessary correction factors to adjust the ampacity for the actual ambient temperature. Fifthly, determine the number of current-carrying conductors in the raceway or cable and apply any necessary derating factors to account for the heat buildup. Finally, the resulting ampacity value is the maximum current that the wire can safely carry in a particular installation. Ignoring these considerations can lead to dangerous situations. Overloaded circuits can cause fires, damage equipment, and create electrical shock hazards. It is always best to err on the side of caution and use the most conservative ampacity value. If you are unsure about any aspect of calculating wire ampacity, it is best to consult with a qualified electrician. A qualified electrician can assess the specific conditions of the installation and ensure that the wiring is installed safely and in accordance with the NEC. Always prioritize safety when working with electricity. Electricity is a powerful force, and it can be very dangerous if not handled properly. Make sure to follow all safety precautions and consult with a qualified professional if you have any questions. The NEC provides a comprehensive set of rules and guidelines for electrical installations. Following these rules helps to ensure the safety of people and property. It is important to stay up to date with the latest version of the NEC, as the code is updated every 3 years to reflect changes in technology and best practices. Understanding the principles of wire ampacity calculation is essential for anyone working with electrical systems. It is a fundamental concept that underlies all safe electrical installations. By taking the time to learn and apply these principles, you can help to prevent electrical hazards and ensure the safety of yourself and others. In addition to the NEC, there are other resources available to help you learn about wire ampacity and electrical safety. These resources include textbooks, online courses, and training programs. It is important to take advantage of these resources to expand your knowledge and skills. When working with electrical systems, always remember to firstly, de-energize the circuit before working on it. Secondly, use properly insulated tools. Thirdly, wear appropriate personal protective equipment such as safety glasses and gloves. Fourthly, never work alone. Fifthly, if you are unsure about anything, consult with a qualified electrician. Electrical safety is everyone's responsibility. By following these simple guidelines, you can help to prevent electrical accidents and injuries. Remember, using the 75 degrees Celsius column when the terminals are rated at 75 degrees Celsius is not just a recommendation, it's a safety requirement. Ignoring this requirement can have serious consequences. So always prioritize safety and use the appropriate ampacity values for your wiring installation. The NEC is not just a set of rules. It is a set of best practices that have been developed over many years by experts in the electrical industry. These practices are designed to protect people and property from electrical hazards. By following the NEC, you are not just complying with the law. You are also ensuring the safety of yourself, your family, and your community. Always remember that electricity is a tool that can be used safely and effectively, but it must be treated with respect. By following the proper procedures and taking the necessary precautions, you can help to prevent electrical accidents and injuries. Therefore, always refer to the 75 degrees Celsius column when your terminals are rated for 75 degrees Celsius to ensure a safe and compliant electrical installation. This practice minimizes the risk of overheating, equipment damage, and potential fire hazards, safeguarding both property and lives. When determining wire ampacity, it's not just about the wire itself, but the entire system, including connectors, terminations, and the environment in which it operates. A holistic approach ensures safety and long-term reliability. Remember that electrical codes and standards are constantly evolving, so continuous learning and staying updated are crucial for electrical professionals and anyone working with electrical systems. Consider taking refresher courses and participating in industry events to remain informed about the latest changes and best practices. Moreover, always document your work and keep accurate records of your electrical installations. This documentation will be valuable for future maintenance, troubleshooting, and any potential modifications to the system. It's also essential to use properly rated and listed components in your electrical installations. This means ensuring that the products you use have been tested and certified by a recognized testing laboratory such as Underwriters Laboratories or UL. Using listed components provides assurance that the products meet certain safety standards and performance requirements. Additionally, when working with electrical panels and enclosures, be sure to maintain proper clearances and working space around the equipment. This allows for safe access for maintenance and repairs and helps to prevent accidental contact with energized parts. Furthermore, pay attention to the grounding and bonding of your electrical system. Proper grounding and bonding are essential for providing a safe path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. In conclusion, calculating wire ampacity correctly is a critical aspect of electrical safety. Always consider the lowest temperature rating of any component in the circuit, apply the appropriate correction and aerating factors, and follow all applicable codes and standards. By doing so, you can help to prevent electrical hazards and ensure the safety of yourself and others. I never hesitate to consult with a qualified electrician if you have any questions or concerns about your electrical system. Remember, safety should always be your top priority when working with electricity.